Now that we know that variables are temporary location in a computer's memory or an application's memory that hold data, the question is, what can we do with these variables or the data that is present in these variables? Well, there are a variety of operators that are present in most programming languages, in all programming languages, and in R, that allow us to perform operations on the data that is present in variables. And there are a variety of different types of operators that we can use. There are arithmetic operators, relational operators, logical operators, and sometimes miscellaneous operators. Arithmetic operators allow us to perform a variety of arithmetic functions, such as addition, subtraction, division, multiplication, so on and so forth. Relational operators allow us to compare data that is present in variables, or really allows us to compare variables. Logical operators allow us to concatenate or check for many forms of relational comparisons simultaneously. And miscellaneous operators such as colon, for instance, allows us to create series of numbers. And these are some operations that we can do with variables. Let's actually see them in action. We are back to our script file, and very simply we can either work with data that is present in variables, or we can work with raw data itself. For instance, I can express for instance an addition operation like this. And over here I have two values, 8 plus 8. The sum of 8 is 16, and so we see that down here. And so we have the addition operation. On the other hand, we could also do something like this. I can have two variables, a number and another number. And I can say a number plus another number. And the result, small issue over here, it says object a number is not found. It's obviously because I did not run that line, a number, because I don't see it in the global environment. So execute that line, I have a number, I have another number, a number plus another number gives me the value 16, which is the same thing as 8 plus 8. Now, one other thing that we can do is we can decide to store the result of a number and another number in a third number. For instance, a third number stores the value of a number plus another number. And we see that a third number holds the value 16 over here, and I can print out that value by typing in a third number. And so I get 16 printed out at the console. Please note that as I express these variables, I am using a certain type of casing convention. You might not actually want to use it, but most programmers do. Most people who write scripts do this, and they rely on a specific type of casing known as Camel Casing. Most organizations, most individuals have their own systems that they use, but Camel Casing is the most common form of casing structure. In Camel Casing, when you have a variable that has many words as part of the name of the variable, the initial letter of that word starts with a capital letter, such as a third number. Similar to the plus operator or the addition operator, we have other operators. Subtraction, for instance, division, multiplication, and even exponents. And so we have a variety of arithmetic operators. Such as addition, which is the plus sign, subtraction, which is the minus sign, division, which is the forward slash, and we have the multiplication operator. Now, And we're all very familiar with these sorts of operators and how to use them. Now, we can use a combinations of these operators together. For instance, let's say I want to get the result of a third number that has been multiplied by the value 64, and I want to divide that by the combination of a number plus another number. And so we see that a third number multiplied by 64 divided by a number and another number gives me the result 64, because obviously a third number is the sum of a number and another number. So that would be 16 multiplied by 64 divided by 16 gives you 64, which is what we find the result over here. Now, R follows an order of operations, which is specifically PEDMAS, which is parentheses, exponent, division, multiplication, addition, subtraction. And so that's basically what has been executed over here to give me the result 64. In addition to typical arithmetic operators, there are a couple of other operators. The first one is that of two percentage signs following each other. And here's the way we can use it. The number 15 percentage 2. The value of that is 1. Two percentage signs following each other gives me the remainder of a long division. So 2 goes into 15 7 times, and the remainder of that is 1. And so we see the remainder of that long division down here. Another operator that's available to us within R gives us the quotient of a long division on the other hand. And so that is a percentage sign followed by a backslash followed by a percentage sign. And so if I say 15 divided by 2, this gives me the value 7, which is the quotient of a long division. Or how many times does 2 actually go into 15? It goes into it 7 times. Now, we can do this with variables as well, or we could do this with raw numbers, as you have seen. In addition to arithmetic operations and arithmetic operators, there are relational operators. There are a variety of different relational operators that are available to us: greater than, less than, greater than equal to, less than equal to, and not equal to. So let's take a look at some of them. Again, please pay attention to our global environment over here. We have a number, another number, and a third number. And so let's compare these variables, right, using relational operators. For instance, let's use the relational operator greater than. Now, if I wanted to know the result of a comparison between two data in two variables, for instance, if a third number is it greater than a number, right? And so this greater than sign allows me to check if a third number is greater than a number, and the result of a relational operation is either true or false. If it's true, that means the comparison that you have made has evaluated true. That means a third number is in fact greater than a number. And if it evaluates to false, that means a third number is not greater than a number. And so basically a relational operator is evaluating the claim that you make in your code. And so over here I say a third number is greater than a number, and the result of that expression is true because a third number is 16, a number is 8. If, on the other hand, I ask the question, is a number greater than a third number, and I run this, I see the result is false, meaning that a number is not greater than a third number. And so other relational operators are as follows. You have your greater than sign, you have your less than sign. And so greater than and less than are basically the mirror images of each other. Then you have your greater than and equal to sign, and then you have your less than and equal to sign. Now to compare actually two variables, so let's say I want to compare whether a number is similar to or is equal to another number, I can do that as follows. A number, is it equal to? Now when we use one equal to sign in R, that is an assignment operator. When we use two equals to signs, that is what is a comparison operator. Two equals to signs asks the question, is a number equal to another number? And so when I execute this, I see that a number is equal to another number. Both have the value 8. And so for comparison of two variables, you would use double equals to. And to see if they are not equal to each other, you have exclamation point equal to. And for instance, if I wanted to check if a number is a number not equal to, let's say, var 3. And if a number is not equal to var 3, the result of that should be true. And so var 3 has the value, this is a string of characters. A number has the value 8. And so obviously these two are not equal to each other, and that is expressed as true. And so there are a variety of relational operators, and these relational operators allow you to compare values in the R environment. In addition to relational operators, one also has logical operators. Logical operators allow you to evaluate multiple comparisons, multiple relational checks simultaneously. For instance, I have a couple of different variables over here. And so one thing I could do is I could check, for instance, is a number greater than or equal to another number? And so when I use two ampersand signs, I am checking multiple conditions existing simultaneously. Is a number greater than or equal to another number? And is var1 greater than var2? And in this case, I'm going to make it a capital var1 because I have capital var1 and var2 over here. And so I'm checking if a number is greater than or equal to another number and var1 greater than var2. And if you execute this line, you will see the result is true. The result is true because a number is in fact not just greater, it is equal to another number. So obviously this part of the expression evaluates to true. The first half of the expression evaluates to true. The second condition that is being checked is if var1 is greater than var2, var1 is 3, var2 is 2, so yes, that is also true. And so because both parts of this expression are true, the combination evaluates to true, which is why we have the true over here. On the other hand, if I just said, is a number greater than another number and var1 greater than var2, this will evaluate to false because a number is not greater than another number. It is equal to another number. And so the relational operator, the two ampersand signs, represent the AND expression, allowing us to check multiple conditions being true simultaneously. On the other hand, we have the OR. And the OR operator are two vertical lines or two pipes. The pipe key is the shift. If you press the shift button and the key right above enter or return gives you the pipe symbol. And two vertical lines, two pipe symbols, represent the OR operator. In this case, I'm checking if a number is greater than another number, or var1 greater than var2. Now, in this case, either one of these should be true for this entire expression to return true. And so, in this case, var1. In this case, the result of this entire expression is true because while a number is not greater than another number, var1 is in fact greater than var2, returning a true from this entire expression. Now R provides a miscellaneous operator, which is the colon. The colon operator is used to generate a series of numbers. For instance, if I want a series of numbers from 1 to 10, if I do 1 colon 10, I get a series of numbers from 1 to 10. And I can store these series in a variable. Over here, I have a variable called num to 10 that can store the result of this 1 colon 10. And so if I type in num to 10, I get the values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so the colon operator is a miscellaneous operator that allows us to generate series of numbers.